Alright, so with a raised hand, can anybody tell me what a three-sided figure like this is? Anna. A triangle. Let's see what a four-sided figure is. Christian.
A square.
Anybody else?
No.
Devin. Quadrilateral. So listen. I know. It's very common. So listen. Quadrilaterals are four-sided figures. A square is also a quadrilateral. Okay? I used to give this example all the time. I don't have a dog anymore, so it kind of doesn't work anymore. But I had a poodle. Sad day. I had a poodle, and he was a dog, right? All poodles are dogs. But not all dogs are poodles. Okay, so a square is a type of quadrilateral. But if you're writing down the name of a four-sided figure, it will always be a quadrilateral. Okay? What is a five-sided figure, Miles?
Pentagon.
Pentagon. And a six-sided figure, Kieran? Hexagon. Perfect. So you're actually going to need to know 1 through 12. You probably know a significant amount of them. I'm going to show you them on the screen. You'll see. All right? So this is just a side note for the scavenger hunt yesterday. I said that you could come after school today. I honestly don't think that I will be here after school. I'm just trying to make it to 2 o'clock when it's 6 hours over, and that's my last class. So you can come anytime during lunch, like today lunch, tomorrow lunch, Thursday lunch, okay, to finish it. It is your first grade. You haven't done it, and neither have you, Donald. But we could talk about it after class. All right, so getting back to lesson 7.1, you're going to learn about angles of polygons. Can anybody tell me what a polygon is, other than those two? Any guesses?
Geometrical figures.
It is. What's another word, do you think, Devin?
Any shape that's not curved or... Oh, no, it can be curved.
It can't be curved, but you got it.
Curved. It has to be closed.
It has to be closed. Wow, when did you guys learn this? So it has to be closed, and it has to be straight lines. So a circle is not a polygon because it's curved and not made of straight lines. All right, so you're going to learn about all of the angles inside of the polygons. You already know about one polygon and its angles. What do the angles inside of a triangle add up to? Anybody?
180.
180. Okay, so if you know that, you can get the rest of this lesson easy peasy, lemon squeezy. So today we're going to learn about interior angles. Tomorrow you're going to learn about exterior angles. But we're going to start on page 197 of your student journal. So page 197.
Are we supposed to label these shapes that we wrote?
No, we're going to actually do something with them in a few minutes. All right, so in a polygon, no, you're not. Put it away. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices. What is another name for consecutive? No? Consecutive?
It never ends.
If you have consecutive state championship titles, what is consecutive?
Back to back.
Back to back, thank you. So, consecutive vertices are on the same line. So, B and C, so if you look at them, I highlighted them for you. They're on the same side. Those are called consecutive because they're right next to each other. Or C and D, those are consecutive. D and E, those are consecutive. E and A. So, what happens is you can create what you call a diagonal in a polygon, and that will help you find the measure of all of the angles. So what happens when you get higher up into maths? In college, your professor is going to show you how you get to all of these theorems. Does that make sense? So the first part of this lesson is showing you why this formula is this formula, okay? You have drawn those four shapes because I'm going to show you how we get to our formula, okay? So the importance of a diagonal is because diagonals in a polygon will form a triangle, okay? All right, so we're going to talk about them. These are the four that you have drawn on your page. What's going to happen is we're going to see how many diagonals we can draw inside of these pictures. Diagonals are lines that are formed to opposite vertices, okay, to non-consecutive vertices. So if you look at what I've highlighted on this triangle, a non-consecutive vertice has to be a vertice that is not right next to the one I've highlighted. Are there any in this triangle? No, so you can't draw any diagonals in a triangle. What about this quadrilateral?
Yes.
Can I draw a diagonal?
Yes.
Yes. I can draw one. Well, what if I drew from this direction? I can draw one. Okay, I can at most only draw one from one particular vertice. Okay? The reason this matters, how many degrees fit inside of a triangle? 180. Okay, so if a quadrilateral has two triangles, how many angles fit, or how many degrees fit inside of that? 360, because there are two triangles, and 180 and 180 make 360. Well, let's do our pentagon. How many diagonals can we make?
One.
I see I can do this one. Can I do another?
Yes.
Two.
I can. I can make two diagonals.
Three.
So I have 3. You can't make a diagonal right next to it, or that would be the side. So we have,
You can't go side to side? Yeah.
you can, but you can only use from one diagonal. So 1, 2. It still doesn't matter which one you choose. You still can only form 2 diagonals at most. So how many triangles can we form in a pentagon? 3. So if you notice, there's a pattern happening. How many sides are in a quadrilateral? 4. How many triangles could we draw? 2. How many sides are in a pentagon? 5. How many triangles could we draw? 3. So if you have a hexagon that's 6 sides, how many triangles do you think you can draw? 4. 1, 2, 3, and there's 4. Okay, so you'd have 180 4 times. What was that, 72? 720? 720. So what happens is, there's actually a formula to do this, okay? So the formula that you want to write down to find the measure, so you want to be writing this down with your pencil or your pen, to find the measure of the interior angles in a polygon, in any polygon for that matter. The formula is n minus 2 times 180. What do you think n represents in the formula?
So, diagonals.
No?
Is it like a certain word?
Well, what word starts with n that deals with math?
Negative.
Okay, no, not that one. The number of sides. So what happens is, the number of sides minus 2 times 180. The reason this is, how many sides were in a quadrilateral?
2.
How many sides? 4. If you plugged in 4, 4 minus 2 is 2, meaning you can form 2 triangles in there. And then 2 times 180 was 360. So if you use this formula for a 6-sided, 7-sided, 99-sided, any kind of polygon, you're going to find the number or the measure of the interior angles. Okay? I think this next chart just kind of shows you the pattern. There's always 2 less triangles than there are sides. So like 4 sides, 2 triangles. That's how we got 360. This one is going to be very important to us. Pentagon, there were 5 sides, 3 triangles, which makes 540 whenever it decides to pop up. Then hexagon was 6 and 4, which makes 720. Okay, so it'll pop up, the formula down here. I just thought it was simpler to write it for you guys. But that's how they came to find this. They used triangles and then moved on. Okay, so we're going to go in our student journal, page 199. So if you flip to the next page, we're going to do some examples using our formula. Okay, so if you notice, they said the word octagon. Okay? How many sides does an octagon have? 8. Okay, so if you find in a few minutes that your answer is like a 7-sided polygon, you have to actually name it. If it's larger than the number 12, like 15, there is a technical name for it, but I'm not going to require you to know it. Okay, so you can write 15, gone. 24, gone. Okay? So anyways, back to this. So find the number of the measures of the interior angles of the indicated convex polygon. So you use the same formula, n minus 2 times 180. We said the number of sides in an octagon are 8. 10 is called a decagon. It's okay. Everyone makes mistakes. So 8 minus 2 is 6 times 180. Pretty sure it's 1080. Am I right?
Yes.
Boom. So in an octagon, it can fit 1,080 degrees. It's intense. Number 2 of 15 gone. So how many sides are there?
15.
15. So for n, you write 15 minus 2 times 180. So 15 minus 2 is?
13?
13. It's okay. You just got back. 13 times 180 is?
2340.
2340
Good job.
degrees. So, you're going to go to your classwork paper. You should be doing it in your student journal. It's okay. So, you're going to go to your classwork paper. Okay, this is the paper that you're going to turn in. And you're going to do number 3. Find the sum of the measures of a 24 gon.
24.
Number 3, yes. Oh, okay, so we're going to start on the second section. It's going to be the opposite. It gives you the degrees, and you have to figure out what kind of shape it is. Turn around. So hold on. I'm going to show you. So look, before I get to it, if your answers come out, so you'll see in a second, if your answer comes out to like a 6-sided polygon, you can't write 6 gon. What would you write? Hexagon. If you got a 10, you don't write 10 gon, you write decagon. The only ones that I will allow you to write gon is above 12.
Wait, so there's a name for those, though?
There is a name. So what happens is, you guys know what a prefix is? It's the beginning of a word. What is a prefix for the number 3? Tri. Close. So what happens is, you see how 10 is decagon?
Yeah.
So for 13, it's tri.
Tridecagon. Ooh.
For 15, it's penta. Decagon. For 18,
sound like a
it's
dinosaur.
octadecagon. So you see what I'm saying? There are names. I'm not going to require you to know them. There's even a name for a 98-sided polygon or whatever.
What's it called?
What about 14?
It's not quad. Last time I checked. It's actually a weirder one. I could look it up after. I don't think it's quadradecagon. It's something weirder. I don't know. But anyways, these are the ones that I'll ask you to know. I'll bring this page back up right after we do our couple problems. But I'm going to tell you that on your classwork and in your future problems, if you don't write pentagon and you write 5 gon, it's not going to fly with me because you are smarter than that. Capiche? So 3 through 12, you should be somewhat familiar with. Okay, hendecagon is probably the hardest one. Okay, when I got into college, there's a reason I asked for these two. I got into college, and my advisor asked why I wanted to be a math major, whatever. I told him, and then he quizzed me on all of these. Like, that was apparently the most basic piece of information I need to know. So, it's just something I ask of you. So, that's it. We're going to go back, okay?
I got a question.
Let's do this first. Okay? You can ask me on the next slide. All right. So, the sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. Whenever you see the word classify, it literally just means tell me the name of it. Okay? So, what is the general formula to find the interior angles? You just wrote it down.
N minus 2 times 180.
Okay, so. All right, so normally we plug in for n. What does n represent?
Numbers.
Number of sides. But we don't know that here, do we?
No.
What we do know is that whatever number we plugged in, minus 2 times 180, it equals 900 degrees. So what you do from here, you don't subtract first.
You divide by 180.
Divide by 180. Yep. So you're doing the backwards. So before you subtracted 2 and then multiplied, you're going to do the exact opposite. To get rid of that 180, you're going to divide both sides. Okay? This minus 2 is in parentheses, so you can't actually touch it until there's nothing else besides n minus 2 on the left. So divide by 180. On the left, you'll have n minus 2 left. On the right, what is 900 divided by 180? All right, so 5. Add 2. So what was n that we plugged in?
7.
7. So what I'm telling you right now is if you stop here and circle this answer, it's not going to be hunky-dory. What is a 7-sided figure called? Heptagon. So your answer should be heptagon. Someone hiccuped. Leave it alone. Someone hiccuped. Leave it alone. So heptagon. All right, we're going to do the second as well. Okay? So number 5, you do the same thing. We're going to write our formula, n minus 2 times 180, and it equals 1620. Okay, so I want to get n by itself, which means I need to get n minus 2 by itself. So what do I do first? Divide by 180. What is 1620 divided by 180? Is it 9? Add 2. N equals 11. This is hen.
Hendo-decagon.
And decagon. Hen decagon. That's 11.
Wait, so 3 is triangles.
Yes.
Then what would
Cool.
13 be?
Try.
Oh,
Decagon.
yeah, I'm tripping.
You're okay.
Bro, shut up.
3 is. Stop. 3 is triangle. It's okay. He asked what 13 was. So try and then decagon. It's okay. So if you get larger than 12, just write that number. Gone. Okay? You're going to do number 6 on your classwork paper.
Oh my gosh. So that was
Because you don't have...
So that wasn't just classwork, right?
Did it say the word classwork on it? No?
Oh my.
Oh my goodness.
But I'm putting classwork for the ones that are classwork.
You know it's in your student journal, right? All I'm doing is going to the next slide. These are the names of 3 through 12. Okay? Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, numbergon. So, you're going to open up your textbook, page 364. You're going to do 10 more problems on this classwork paper. 364. You're going to do 1 through 10. Here is what I'm going to tell you about number 2 when you get there. You're doing 1 through 10. I'm going to tell you about number 2. 3, 6, 4. 7.1. So is everyone looking at number 2? Trying to help you. Can I get an amen when you get there? Amen.
Wait, what page?
You're lucky it's your first day back. Could go on a rant. Okay. So number 2, it says which. Can't read upside down. Which sum does not belong with the other three. Explain your reasoning. So the four options: the sum of the measures of the interior angles of a quadrilateral, the sum of the measures of the interior angles of a pentagon, the sum of the measures of the exterior angles of a quadrilateral, and the sum of the measures of an exterior angles of a pentagon. So you haven't learned the exterior measures. So I want you to flip, what is that, to the right? Go back one page. Page 362. If you look on the bottom of page 362, you'll learn this tomorrow. It is the most simple theorem. It says the sum of the measures of the exterior angles of a convex polygon. Any polygon. One angle at each vertex is 360. So it does not matter if you have a dodecagon, a 99-sided polygon. The measure of the exterior angles is always 360. You're going to see that a lot tomorrow, but that will help you with number 2. Okay? So the sum of all exterior angles on any shape is
360.
360. Thank you, Christian. So you're doing 1 through 10, and then we're going to grade them. Okay? Go.
Okay, let's do this.